Alright, good morning class. Today's class should be under Ohm's Law. Just like I stated before that we are going to start this very electric charge bit by bit. So today is going to be an Ohm's Law. We've been discussing issues under electric charges, and today the Ohm's Law is going to be discussed. Ohm's Law is just a statement made by a scientist called an Ohm. He states that the potential difference across a metallic conductor is directly proportional to the current flowing through it when the temperature of the conductor and pressure are constant. So this statement will be analyzed mathematically down here on the paper. So follow me and see how it's going to be. Like I said, the Ohm's law statement will be analyzed on the paper. The Ohms said the potential difference across a conductor is directly proportional to the current flowing through that very conductor. Now, this is constant of proportionality that can be removed. When we remove this constant of proportionality, we are going to introduce I, equal sign, and R. So automatically the Ohm's law becomes V equals to I R. This is called an Ohm's law, where the V is the potential difference across the metallic conductor, I is the current flowing through the conductor in ampere. The SI unit is ampere for the current, while R is the resistance of the conductor, in ohms. That means the potential difference has a unit volts, while the current has a unit of ampere, and the resistance has unit of ohm. The ohm is written this way. This is how the ohms will be written. So this is what is called an Ohm's law. Every conductor has its own different resistance, but some materials or some substances or metals can accept the Ohm's law. They can obey Ohm's law because they have resistance to them. They can conduct electricity, while other substances cannot. Every substance that can conduct electricity is called a good conductor of electricity, while those ones that cannot conduct are called bad conductors of electricity. So mostly all the good conductors of electricity can conduct electricity, can obey also an Ohm's law. Again, we can see how we can find some problems related to this very Ohm's law. Since the formula is this way, that's V equals to IR, so sometimes V can be given, I can be given, and you are asked to calculate R, the resistance, simple. Or sometimes the resistance and the potential difference should be given, current will be asked to calculate. Or current and resistance will be given, you'll be asked to find the potential difference, simple. Now let's see how we can solve one or two examples under this Ohm's law. Alright, we are into example number 1 that says calculate the potential difference across a metallic conductor of resistance 20 ohms when delivering a current of 2 ampere. So after writing solution, what next to have is data given. After data given, we'll read it. Calculate the potential difference, that is D equals to question mark across a metallic conductor of resistance R capital equals to 20 ohms when delivering a current of 2 ampere, that is I equals to 2 ampere. Now automatically our potential difference is V equals to IR. So using this, you can be able to get your potential difference by substituting I with just 2 ampere times R, which is just 20. Now potential difference will be equals to 2 times 20, which is 40 volt. So this is how somebody can use this formula to calculate the potential difference across a metallic conductor. You shouldn't surprise when sometimes it's not the potential difference will be asked. You may be asked to calculate current when V is given, R is given, or sometimes you may be asked to calculate R when I is given, V is also given. Assuming this I is not given, V is 40, R is 20. Let's see how we can calculate the current. Like I said, I is question mark, V is being calculated as 40 volts. Then R was just 20 ohms. Using this relationship still, V equals to IR. We can be able to find our I by saying divide both sides by R. R cancel R, you're now left with I equals to V over R. This is equals to 40 divided by 20. This cancel this. I equals to 4 divided by 2 is 2 ampere. Simple. If you are asked to find the resistance when I is 2, V is 40, still can be calculated easily. It can be calculated easily by saying V equals to 40 volts. I equals to 2 ampere. R is question mark. Using that same relationship as V equals to IR. V is 40, I is 2, then R should be easily calculated. Dividing both sides by 2, 2 cancel 2. You're left with R equals to 40 by 2 is 20 ohms. You see how we parabolate in within one example. This is third example. This one is second example. And the other one is first example. It is very simple and straightforward. There is nothing more bigger than this in calculations under Ohm's law. Thank you. Let's see how we can explain the other parameters of the Ohm's law. Thank you. Alright, students. We've been saying potential differences, but we still didn't know what is called potential difference. Now, what do we mean by potential difference? By definition, potential difference means a work done in carrying one coulomb of a charge from one point to another within a conductor. Let's see an example here. Assuming this is a circuit. With a cell here, positive charge, negative. This is a closed circuit, assuming. Now, what we mean by potential difference, looking at this point, is the first point within the terminal. The work done in carrying one column of a charge from this point to any point within here is what is called a potential difference. At this point, there is a potential PA. When the charge moves here to here, another point P, which is PB, point A, point B. There is potential between point A and point B. Now, what is potential difference? The potential difference between the 2 points equals to potential at B minus potential at A. So this is what is called potential difference, and everything measures in volts. Now, unlike electromotive force is different with potential difference, but they have the same SI unit. In definition, they are different. In nature and everything, they are totally different. But electromotive force is a work done in carrying one coulomb of a charge from positive terminal back to negative terminal around the circuit. Taking a charge from here, around here to here is what is called an electromotive force when the key is closed. So if you close the key, if there is a key here, you close this very key, the charge will be going around the circuit constantly. So in this case, we have what is called an electromotive force. But when the key is open, that electromotive force converted to potential differences. When the key is open, it is called potential difference, but when the key is closed, it is called electromotive force. So in a nutshell, this is what is called electromotive force and potential differences. All of them are very, very useful when it comes to electricity.